Hello everyone. In this video, we'll be discussing CS1 Paper B, April 2023 solution, indicative solutions. These solutions in true and best of my knowledge. Let's discuss this paper. Question 1. Simulate 10,000 values from a normal 0,1 distribution. Using an appropriate R command, you should have generated values in R for later use. So, I have assumed a set seed value of 123. This is again an assumption. You might not use it. I have used it so that there is no change in the answers further. And I've used R norm 10,000 0,1 because it says from a normal 0,1 distribution. Okay. Simulate 10,000 values from a chi-square distribution for using an appropriate R command. You should have generated R values. So again, this is R chi-sq 10,000, 4. Okay, directly from a chi-square distribution. It says discuss the main disadvantage of using the inverse transform method for simulating values from a chi-square distribution. The PDF of chi-square is directly not straightforward. Hence, using the transform method will be very complicated. Hence, we have probability tables for chi-square distribution. Okay. For this says simulate 10,000 values from a T4 distribution using our answers to part 1 and 2 and explaining your answer. So it says using part 1 and 2. Directly we have T distribution inbuilt in R as well, but since it says using the distribute of part 1 and 2, so we'll use X by SQRT of Y by 4 because the formula for a T distribution is nothing but a normal 0,1 distribution Z values divided by root over of chi-square values by the degrees of freedom will give me the values from a T distribution. Okay. So if we run Z, we get values like this. Okay. Explaining your answer, if a variable has a chi-square distribution with n degrees of freedom and Z from a normal T distribution, and T distribution with n degrees of freedom is given by the above formula and has said to have the same degrees of freedom. So this is a T4 distribution. Okay. Simulate 10,000 values from a T20 distribution and modifying R code from 1, 2, and 4 necessarily. So I've copied the same codes and then just this remains same, only chi-square becomes 20 and here also it becomes 20 in Z1. And then demonstrate an important property of the T distribution by presenting and comparing two appropriate plots of values determined in part 4 and part 5. So if you see, I'll draw two plots, plot of density of Z and plot of density of Z1. Both of them give a similar graph. If you see, okay, you can put your main and y-axis, x-axis. It is a symmetrical distribution. Okay, it is symmetrical about the time 0. So it follows normal distribution with any degrees of freedom. The shape almost remains the same. You can draw a histogram also instead of drawing. If you do not want to draw, if you do not get this stripe, you can draw a histogram of Z as well. Okay, and histogram of Z1 as well. Both works completely fine. Okay, you will see it's symmetrical about the 0. Then next question. Question 1 was pretty straightforward. Question 2. Consider a sample of 1,000 insurance policies. For each policy, there is a record of whether the policyholder has submitted at least one claim during the 6-month period, the age of the policyholder, and the duration of the policy. The number of policies X with one or more submitted claims is modeled as a random variable with binomial X, 10,000, P. State the underlying assumptions that led to the choice of a binomial distribution. It might be everyone has thought differently, but the basic underlying assumption is that since either there can be no claim or there can be at least one claim. So either because there are only two, a no or a yes, so we have taken a binomial distribution. Okay. Use the load command to load the CS1 policies R data. This was provided in the pre-work material. To load the observed data into R, this will create a data frame called CS1 policies with 3 entries: age, duration, and claimed. Okay, age, duration, and claim takes the value 0 or 1. And actually wishes to fit generalized linear models of the data, assuming that the number of policies with one or more submitted claims is a binomial distribution, and the link function of the GLM is the logit function. Fit a GLM says that P depends on the age of the policyholder and report the estimated parameter values. So fit one, if I say GLM claim, so this is ZWD load, and if you see, first load this name. So if I have age, duration, and claim, GLM of claimed tilde age family is equals to binomial, link is equals to log it, and this is my fit one. So this equation is my only the age is 0.02, the intercept for this y is equals to mx plus c basically. So c is my minus 2.36 and m is my 0.02, this value, and I have an AIC of 1056 for this. Okay, now next one, it only depends on the duration and report the estimated parameter. We will only change the function to duration with fit to. So I have here AIC is 953 and again C is 0.3906 and duration M is minus 0.6, a negative slope basically. Compare the fit of the model in part 2 and part 3 using deviance of the archaic formation. So if you see the deviance for residual deviance for this value, it is 1052 and it is AIC is 1056, whereas here it's 949 and 953. Both values are less than the first model. Hence, fit 2 is a better model than fit 1. Okay. Then I have fit a GLM to the data that depends both on the age and duration and report the estimated parameter values. Now we have fit 3. Now it says both. So both I have taken age, duration and the interactive term between them. Okay. It might be possible that most of you missed out on the interactive term. It's not mentioned. So it can be that it does not have to include it, but you can include as well. There's no problem. So this is fit 3 and fit 3, if you see, it has a lower AIC than all the three. The height was 952, here it's 946 and the lower deviance also. So all the three, fit 3 is the best fit, which is the next part. Okay, means one line code is achieving you 5 marks directly. Okay, and you can show this directly this. Next question, question 3. You see, this is done. Question 3 is height. The file heights.r data contains the R data frame heights that consists of a random sample of heights of mothers, fathers, and their daughters. Draw a scatter plot for each pair of the data. So again, this is their load heights.r data, and plot, you can just directly do heights. Main is equals to a scatter plot. So you get a scatter plot out here, which is plotting this correlation between each of them. If you see mother to father is a weak positive correlation. Mother to daughter is a little stronger positive correlation. Father to mother is similar. Father to daughter is also a positive correlation, but weak positive correlation. Okay. So we have these three observations from here. Comment on the relationships you've done. Fit a multiple linear regression model with daughter's height as a response variable and mother and father as explanatory variables. So again, I've just drawn a fit LM daughter, mother height plus father height. And once you do this, you get summary of fit because you've told to review the summary. And answer show a summary of the output and the fitted equation. So you can write the fitted equation. The fitted equation will be 7.45 plus 0.70x plus 0.1 x1 plus 0.16 x2. This you need to write. Okay. And if you see, it says assess the effect of each explanatory variable. So mother's height is a more mother height is more significant since it has a p-value which is less than p-value which is less than 0.05 and father's height is greater than, so it can be ignored. It is not that significant than mother's height. Okay, that is there. Next, it says plot the residuals of the model fitted in part 3 using a graph that is appropriate for checking the estimated errors are independent of the explanatory variables. So first plot we see is explanatory, where we see residual versus fitted. It does not follow any trend. There's no random trend. There are some outliers in the data. So when there's no trend, we say that the fitted variables are independent of the explanatory variables. Okay, the errors are independent of the explanatory variables. It is they do not have any trend in the data. And comment of the fit of the model appears to be the good fit because residuals do not have any patterns. Okay. A suggestion is made that when the daughter's height is 61 and the father's height is 63, the daughter's height should be 67.5 inches. So new data, mother height 61, father height 63. Predict fit, new data, we have to predict a 95% predictive interval. So predict new data interval is equal to predict. If you see, the confidence interval lies between 56 to 65, whereas the question says the height should be 67.5. So the claim is unlikely. Okay, the claim is not likely, and 95% CI is only 56 to 65 inches. Again, a very direct question, very easy paper, very not at all time taking. Next is this EBCT sum which has come up. The table below shows the claim amounts thousands per year over a 5-year period for 5 insurance companies. The data can be entered into an R matrix. You just need to copy this code and run. Okay, then we have to calculate the EBCT model 1, EM theta. EM theta for EBCT model 1. These are direct formulas. So XM is equals to mean of row means of claims, which is 3383.2. Then variance of M theta and expectation of X theta. First, we'll calculate expectation of X square theta, which is row variance. Apply claims 1, where, and S is mean of row dot where. If you run S, my expectation of S square theta is 188,47450. Variance of M theta V is equal to variance of row means of claims minus S, which is expectation of S square, divided by N polar claims. So V is this 3232667. Okay, we got this. Calculate the expected claim amount for company E using your answers from part 1. So Z is my N pole of claims divided by N pole of claims plus SYV. Okay. And then using the only for company E, we need to calculate. So claims of 5, we need the row 5 plus 1 minus Z. So this gives us 2090.906. Okay. Then calculate the expected claim amount for company E using your answers from part 1. We have done this. Then table below gives you given volumes, and from this volumes we need to calculate the EBCT model to EM. So again, copying the code, you just have N, which is N is the number of columns, N pole of claims, and capital N is N row of claims. X is claims by volumes. XI bar is each the mean of each row sums of and volume sum. PI is row sums of volumes and P is sum of PI. P star is nothing but sum of PI into 1 minus PI by P into N into N. This is again given in the tables. M is, which is expectation of M of theta, sum of claims by P. S is nothing but mean of row. So M answer is 7.319. Mean of row sums volume into xi bar, x minus xi bar by n minus 1. So if you run this, the S answer will be 4356, and V is sum of row sums volumes into x minus m. This, if you run, V is this. Zi is nothing but Pi by Pi plus S by V. Credibility is Zi 5 into Xi bar 5, because again, we have been told that company E you need to calculate, and the following year the company model remains 130. So Zi 5 into X7, 1 minus Zi 5 into M. So this gives me a credibility factor of 8.74, and expected claim is credibility factor into the 130, which is the following. So I get an answer of 1136.293. Okay. So now next part again is a comment part, difference between the two models, EBCT model 1 and earlier by comparing your answers in part 2 and part 4. So there's a difference between the answers because of the volumes being incorporated in model 2, nothing else, and other differences you can find in the material and you can write as per your knowledge. Okay. So that was this paper. It was also a very easy paper and comprised directly from the our CS1 concepts, if you all know that.